Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to the Advanced Aquaculture Technology course. My name is Professor Gauravdhar Bhomik. I am from the Agriculture and Food Engineering Department of IIT Kharagpur. So, in this particular lecture, we will be discussing about the flow-through system for the module 2 technology of closed aquaculture. The concepts that I will be covering in this particular lecture is the introduction to the flow-through systems. What are the type of flow-through systems like conventional one, intensive ones, and what are the merits and demerits related to this kind of flow-through systems. Flow-through systems, it's actually intensive land-based aquaculture systems. So, in general, we use this kind of systems is not used in semi-intensive or the extensive aquaculture because it does not make sense to involve this much of in the design and the engineering prospects involved with this these particular flow through systems are not viable for other aquaculture units like other than intensive ones. It involves rearing fishes at high stocking density in long or narrow ponds or tanks. It requires abundant amount of continuous water flow. So, that is the reason why it is called flow through systems. It facilitates the high degree of control over the environment for the species that we are culturing in our aquaculture pond or in aquaculture raceway, like in aquaculture pond or aquaculture tank, whatever it is. Okay. In the flow through systems, the most common facilities are like involved with the trout culture, different kind of trout, rainbow trouts and etc. So, this is very much famous in all the western countries in general, and also in India also we are using it nowadays in a large number. Continuous flow of this water actually which is happening in this kind of flow through systems, which actually ensure the proper oxygenation and also flushes out all the metabolic waste that is generated out of the aquaculture species and all. Okay. So, in general the systems, this kind of flow through system, it usually in the shape of rectangle. Definitely we try to make it in a rectangle shape in general. Okay, I will discuss you I will show you the picture how it looks like. So, other than that it can be circular, there are possibility of making it in other shapes as well, but rectangular are the one which is like a very famous one and which we normally try to have it in our system, in our farm and all. It generally designed made of reinforced concrete or the earthen material with the inner surface covered with plastic or the nylon material. Sometimes it can be of only plastic material, or nowadays we use this HDPs and all. Okay, so that can also be used, and there are possibility of using it, designing it with the FRP materials also, like fiber reinforced plastics and all. Other than that, metal or wooden based flow through systems are also there depending upon the place of culture and all. The water supply, it can be of two types. In general, the conventional one is like you are providing water in the same direction and just keep on going, keep on flowing through it. And there is another one, intensive, where we have the intensive, when we go for further higher stocking density, we have to provide it with the additional amount of the water supply units, which we considered as the intensive water supply systems. This is a standard schematic diagram of representation of the flow through tanks, the water sampling. You can see the the water meter from the water supply line through the water supply pipe. The water is coming, which is like INF, means like inflow. The inflow is coming to the the culture tank, where the we normally go for this makeup water sampling. Okay, that water sampling is done there. Then in the water tank, in the fish tank, the fish or whatever the culture species we are targeting, those are being those normally are being reared. There we have this water sampling units, you can see WS there. These units, these sampling units are used for continuous monitoring of the quality of the water that you are supplying and the quality of the water that is prevailing in the tank. So it is very much like predominantly use this kind of sampling techniques and grab sampling or okay. So then from this fish tank, the water is coming out, it comes to this this soil separator. So why do we need this kind of soil separators? All the actually the amount of the waste that is generated from this intensive aquaculture units are very high. Okay. In general, they have this very huge amount of suspended solid. They can have a huge amount of nitrogen species and also, which are also converted into the biomass, and they can also be sedimented there, and those solid material, those suspended solid materials are actually being collected and it's separated using this soil separators units. In the soil separator units, you can see in the vortex region, that it generates the vortex region and have this hooper like structure at the end. So we can get the sludge discharge, you can see SD, this sludge discharge unit. So from that we get the sludge out of it, which are in general the thickened slurry kind of, it looks like thickened slurry, and this slurry is actually very rich in different nutrients and all. So we want sometimes to be like, this kind of biomass, this kind of, like the sludge actually has a very high potential to be used for different purposes. So normally it is used for fertilization, biofertilizer application. We can use it for different other purposes as well, like we can get some byproduct recovery also from these systems, and we can use it for fertilization and all. Anyway, so this soil separators at the end of the at the end, when the system is actually getting rid of all the solids present, at least like as much as possible, the solids from the water, then the clean water is going out of the from the top of it. Okay. So you can see the supernatant of this soil separator unit is going OUF, you can see the outflow. So through that way, so it is getting out. So all this WS is the point where the water sampling is taking place. So based on the water sampling are the data that is available. So what are the data that we need to normally look for? The suspended solid. So the solid, it can be of different types, suspended solid, it can be dissolved solid, etc. So what is suspended solid? Okay, there are other solids material as well. In general, what you need to know, what is suspended solid? The one which is in suspension all the time in the water. Okay. So the one which is dissolved in it, we dissolve in it, which is very hard to segregate from this water. It's like we call it the dissolved solids and all. Okay. And the other one which is having which is in a suspended solid, that we can easily take out using the simple filtration method. We can use this soil separator method, where we can make a vortex. So the centrifugal force, what will happen, the stuff, the material, the elements with the higher specific gravity will be in the peripheral region, and in the peripheral region and all, it will keep on accumulating in the bottom. Or like there are like technologies, you already know what is how to use this kind of physical this phenomena to getting rid of the solid particles from the wastewater. So after the solid particle is we can get rid of the solid particle, the clean water that is coming out of the system is actually again be used, reused, can be reused back to the tank, and also it is good enough to throw it to the surface water bodies. But make sure that you have checked the water quality of that before throwing into the surface water bodies, because in Indian context, Central Pollution Control Board has very strict rules and regulations like related to the surface water discharge. So you have to abide by those rules and regulations. You have to abide by all the parameters, whether it be pH of the water. If the pH is up and down, like it's not at the range that it requires, you have to go for neutralization techniques and all. Okay, if the it depends, depending upon the various parameters. If the solid concentration is still very high, you cannot still throw it into the solid water, into the surface water bodies. You have to make sure that the solid is completely removed. If the suppose the alkalinity is very high, if suppose the hardness is very high or low, so all these parameters. Okay, so first of all I would like to request you to get an idea about what are the water quality parameters: pH, DO, alkalinity, hardness, nitrogen content. Nitrogen content can be different type: total nitrogen content, total ammoniacal nitrogen, total gel nitrogen. Okay, so these are different terms that you need to understand. Okay, you need to learn. You can just simply Google it, it's very easy. Okay, even if it's not, then maybe we'll discuss it during our live session that we'll be having. So there also I'll discuss with you all these parameters and how these parameters are very much needed. You need to know these parameters in order to understand or the design your aquaculture farm in future, because it related to the water. Aqua is water, right? The water is very important, and you need to know each and every segments of water quality parameters and how those are related to this kind of flow through system or any kind of aquaculture farm that you will be designing. Okay. So in case of conventional flow through systems, the oxygen requirement is delivered by the normally the inflow water. The flow rate of water required for the oxygenation has to be higher than the flow rate required to flush out the metabolic wastage. Okay, so that you have to make sure when you will be designing and or for your own farm, or maybe you are a technology provider or you are a consultant. So when you will be designing it for your customer, and then you have to make sure that the flow rate is designed accordingly, so that it has to be higher than the flow rate required for the flushing out of all the metabolic wastes from your system. The oxygen requirement of the fish, it becomes a very critical factor for the water flow rate calculations, and we can how to do that. The specific flow rate or the Q that we can easily find out by the actual flow rate, which is in meter per hour. Okay, so this water flow, why it is meter per hour? It is actually meter cube per meter square per hour. Okay, so that's why in general we say meter cube of water flowing through within a particular hour or particular time frame for per meter square of surface area of your this flow through system and all. So meter cube by meter square per meter per hour. In short, we say meter per hour. Okay, the W is the actual mass of fish in the tank, kg in kg unit. So if you see the unit for Q, the specific flow rate is meter per kg per hour, isn't it? So Q by W. So that is equal to the DO concentration at the saturation level, which is gram per meter cube, which is CS. What is the DO concentration at saturation level? You need to remember this data. This is very important. You will be asked in any kind of competitive exams. There is a chance you may be asked that in general at 20 degrees Celsius, DO or the dissolved concentration in STP condition at 20 degrees Celsius, it is 9.07 milligram per liter or 9.07 ppm, parts per million. Okay, so that is the DO concentration at saturation level at 20 degrees Celsius. You know that with temperature the DO concentration, the DO value will up and down, right? So based on the temperature, sometimes the DO concentration, saturation DO concentration can be as high as 11, 12, and as it can be as low as 7, 7.5 like that. Okay, depending upon the temperature and all. So in general, when the warmer area, the DO concentration and saturation level is much lesser. In case of colder region, it's much higher, isn't it? That is the reason why we heat the water to get rid of all the gases. This is also standard degassing procedures from the water, right? Then the C is the allowable minimum DO concentration. So suppose we have a allowable minimum DO concentration of around say like 2 milligram per liter. Okay, or like so based on this value and based on the saturation value and based on the specific oxygen consumption rate of the fish, which is gram per hour per kg in general. So that value we can easily find out in the literature. So from that equation, from this equation, you can easily calculate any of the unknown fact from your systems. You can get an idea about the actual water flow required in your system. before, just because when you have, like, while calculating, when you have the idea about the value of R, value of CS and C. So, based from this equation and value of W also, say suppose you know that the actual mass of fish that is available, based on this factor, based on this the numbers, you can easily calculate the actual water flow that is required. Suppose the actual water flow you know, and everything you know from the calculation from the pre-calculation stage. Now all of a sudden you are asked, like, what is the actual mass flow, mass of fish that is available in that tank? That is also doable. So in general it is used for the actual water flow calculation, this equation, and this this you should remember. This is actually more or less same for all kind of flow through systems. Okay. The second one is intensive flow through systems. It's actually developed very recently with the primary aim of increasing the stocking density or decreasing the water flow. In general, the oxygen requirement of the fish is provided by oxygenating the inflow water. What it happens, the water, before it is supplied to the system, supplied to this kind of flow through system, it is oxygenated, okay, by using the oxygenator. What is oxygenated? What does that mean? It means we somehow increase the dissolved oxygen concentration of the inflow water. Okay. So there are various means of doing that. Simply you supply the fresh oxygen using oxygen cylinders. You can supply the fresh air, like from the air circulation aeration units and all. So there are various ways of doing that, but you have to make sure that you are oxygenating your inflow water. So to a certain level that the flow through system has enough amount of oxygen, and so that even the increasing the stocking density will not cause any issue to your system. So that's why it's called intensive flow through systems. Okay. The water flow can be minimized because water flow is for what? To supply the additional oxygen. But if you can supply the minimum, like even less than the water that it requires, and if you can supply it with the enough amount of oxygen that it requires for the survival of your aquatic species, then that's it. That is what we need, right? So that's how we take care of the oxygen requirement of the fish in the system, in this kind of intensive flow through systems, or in short we call it IFTs. Okay. The flow rate needed to flush out the metabolic waste becomes the critical factor for water flow rate calculations. So that is very important, and we need to make sure that the flow rate needed for flush out of the metabolic waste is in the design calculations and all. Okay. The raceways are actually a type of intensive flow through systems. Okay. So this raceway and all that we normally have, normally we design, it's a type of typical example of the intensive flow through systems. So like, okay, so let's talk more about, like, we have a basic idea about what is the flow through systems, what are the different types of flow through systems. Okay. Now let's talk about the advantage and disadvantages, or the pros and cons part of flow through systems. We already know while discussing that we have to make sure that the oxygen is continuously provided, right? So the continuous flow maintains the oxygen level and the temperature, and removes the carbon dioxide and the nitrogenous waste from this kind of flow through systems. If it is intensive one, then the same thing happen, but the flow, like not only the flow but oxygenator involves with the before putting the water into the system, that also help additionally, which also kind of a more advantageous for this kind of intensive flow through systems. Okay. It can facilitate very high production level, 1000 times more than the pond culture. Can you imagine? Like you can, just by introducing this kind of techniques, by introducing some initial capital cost, which we normally, as a Indian context, we normally think like, okay, it is not doable and all. So but the problem is we do not do the economic analysis. We only think about the cost that involves in the beginning. We do not think about the benefit that we will be getting in a subsequent time frame. Okay. So if we can design our system optimally, if we can have our system scientifically designed, and the engineering, the aspects will be done properly, we will definitely get very high amount of production benefits. Okay. So it can go almost 1000 times more than the general pond culture of the same area. Like suppose the same area, if you can compare in a pond, like the production can be 1000 times less than the this flow through systems. It facilitates the discharge of effluent with very lower concentration of solids and nutrients, which is also very much helpful in environment perspective as well. It is relatively easier for feeding, grading and harvesting process, because you do not have to worry about because the feeding is done, you just put an automatic feeder, you can design it accordingly. It will be there will be like relay circuits and all. It will definitely provide you the amount of feed that it requires with time, without any human involvement and all. Okay. What are the disadvantages in it? First of all, the flow through system and the raceways, if it is not incorporated inside a pond or inside it, there are instances where the raceways are incorporated inside a pond. So raceway in pond we call it, okay, raceway in big culture pond. Other than that, it requires a huge amount of water. It's a large amount of water that it requires to exchange a lot. So that is a bad thing. That is the one of the major cons part of this kind of technologies. It is inability to self cleaning, because self cleaning is only possible if we increase the velocity, the flow velocity up to a certain level. But if you increase that flow velocity up to a certain level, what will happen? The fish that the dwelling there, they will not be able to survive in this harsh situations and all. So for them it's a big of a difficulty. This self cleaning procedure is like, if you want to incorporate self cleaning, then definitely for the fish to survive and go to the upstream is really very difficult for them. The dwelling in that zone will be very much they will face a lot of difficulty on it. So that is the same thing, it poses the cleaning difficulties, because it will be like continuous motion and all, but not self cleaning. So that means somehow you have to get rid of all the suspended solids that is being sedimented with time on the bottom of this culture tanks and all. It requires a high amount of dissolved oxygen level maintenance, definitely, because once you do the intensive aquaculture, it means that there are large number of fishes involved with it, right? So when there is large number of fishes involved with it, so definitely you have to involve you have to make sure the dissolved oxygen level of the pond or the tank is never below a certain threshold limit. Okay, it doesn't have to be saturation or doesn't have to be near to saturation level, but it has to be maintain a certain threshold limit based on the culture species that you are culturing in your treatment unit. Also, the culture fishes, they consume more food due to the requirement of the high energy for swimming. Okay, in general, what will happen? It's like, when we do more gym or more physical exercise, we need more amount of food, right? So once they are in the extensive aquaculture systems, though they have a vast area to cover, but they feel like there is no competition, they don't go fast or something. But in case of small aquaculture systems, if you give it a closer look, it's so surprising. Though it has a small area, very less area to dwell, less area to swim, but still it always has a lot of neighboring species, neighboring fishes with it, and it always keeps on moving like here and there. It's like the energy, the swimming, the potential is becoming much higher in case of intensive aquaculture than the extensive one, and which actually involves with a high cost, involves with a large amount of cost for us. How? Because of the involvement of the feed requirements. But it is somehow good. Even sometimes what we should do, before providing the food, you just use a small stick or something if you have a small pond and all, and or if you have some way to help this fish to move fast. And also anyway it is a flow through system, so definitely the fish will swim a lot. Okay, so the moment it will swim a lot, what will happen? It needs a lot of fish feed as well. So but the good thing about this is, like, it's it will be consumed in much higher percentage than in the other intensive aquaculture systems, or than in the other extensive aquaculture or semi-intensive aquaculture systems, because it's keep on running, it's keep on moving from one place to another, and it gives them a huge amount of, how to say, the conversion, biomass conversion, this feed to conversion, biomass conversion ratio is very high in this kind of systems because of that. So the production yield will be higher, however the consumption of feed, which cause you some additional economic involvement and all. In general, the flow through systems are a type of intensive land based aquaculture. These systems characterized as by requirement of abundant continuous water flow. Major disadvantage involves, because like it involves a requirement of high volume of water and the absence of self cleaning ability, and as we discussed, the feed. That is, these are the only like the cons part of this kind of system. So, what will be the takeaway message for the today's lecture? That flow through systems in general involves with a certain it's a intensive land based aquaculture systems which involves with a continuous flow of water in your system, in the unit. It requires abundant amount of continuous water flow. Okay, the water will be keep on flowing. It facilitates the higher production than the traditional pond. I already discussed with you what is the reason behind it, what is the scientific funda behind it. Okay, and they possesses the cleaning difficulties and lacks the self cleaning ability. Scientists are working on it. They have developed different kind of self cleaning raceway ponds nowadays as well. So, where the treatment units, so there is like proper sacking mechanisms which are there. Those sacks are there which will keep on cleaning. With time it will keep on cleaning the bottom of those treatment those flow through systems and all. So, by this way you can clean the systems, you can clean the bottom, and with time, and not only that, if it is a really huge. So, what they do with time to time, they the moment they do the harvesting, the amount of harvesting, say like once in a year or twice in a year depending upon the culture species. So, once the harvesting is done, then they keep on they increase the flow rate. So, once they increase the flow rate and somehow make a certain barricade or certain restriction at a certain point, what will happen? There all the solids will keep on accumulating. Then they go for dredging process and they collect all the the suspended solid or the sedimented particles which are there in the this kind of like system, this flow through systems and all. So, this is how it is done, and this is the technology that is available nowadays in the market already. So, I hope you get to know some new things in today's lecture, and these are the references that I have taken the data from. So, you can go through it, and if you have any difficulties, definitely during the live session you can discuss with me. Okay. Thank you so much. See you in the next lecture video.